Hey, welcome everyone. Today I'm going to teach you how binary search works in very simple and easy way. So first understand that to perform binary search, like data should be sorted. So for example, I have this array. We started from 0 index to 10th index. Okay. Now suppose we want to search 15. Take key as 15. Alright. First we will take three variable, which is L lowest, highest, and width, where lowest is nothing but initial index, which is 0. Highest is nothing but nth index, which is 10th. And to find the mid, we'll just add initial index plus nth index divided by 2. Okay, so in step 1 we'll simply find the mid value because we have the lowest and highest index value here. Okay, so here we will write lowest value is 0, which is 0th index. Highest value is the 10th, which is 10. Okay, now find the mid. 0 plus 10 divided by 2, 5. Now check which element is there in fifth index. So 0, 1, 2, 3, 4, 5. Here we have 12 in fifth index. Okay, so write mid 5 as 12, and here we have key, which is 15. So now compare both of them, like whether the mid value is equal to key or not. Okay, so here we can see that key value is greater than 12, obviously, right? So what we will do is, it means that the element which is key is present in which area? In mid plus 1. Okay, mid plus 1 is what? Like here we can see that here written, here it is 12 and 15 is greater than 12, which simply means that the mid value is greater than 12. What we will do is, we will update that lowest index value to the mid plus 1, which is nothing but here 12 plus 1, like 5 plus 1 here. Okay, so it will become 6. Now again in step 2, update that L into mid plus 1, which will be 5 plus 1 equal to 6. Here mid was 5 now, 5 plus 1, it will be 6. Okay, here 6. Now in step 2 we have lowest index, which is 6, highest index, which is 10, and now we will get this, like divided by 6 plus 10, 16 divided by 2, which is 8. Okay, now in check which element is in 8 index. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8. Here we in 8 index we have 16, so just write that mid 8 equal to 16, and we had key value, which is 15. Okay, now compare both of them, that mid value and key value. So we can see that 16 is greater than 15, right? Obviously. So what we will do is, we'll simply update that h highest value to the mid minus 1. Update that h value which was there to the mid minus 1. Okay, so it will be like, what is mid here? 8. Okay, so 8 minus 1 will be 7, which is here, it got updated here. So h is here, so here it is L, here it is highest. Okay, now in step 3 we have L as 6, H as 7, 7th index. So mid will be 6 plus 7 divided by 2, which is what? 6. Okay, now and we'll find that which value is in 6. So here 0, 1, 2, 3, 4, 5, 6, here it is 14. So mid 6 equal to 14 and key equal to 15. We can see that key value is greater than mid value. Then we will simply update again that lowest index value to the mid plus 1, where mid was 6, so 6 plus 1 equal to 7. So now here both of lowest and highest will become in 7, like so. Here in step 4 we have L lowest equal to 7, highest equal to 7. Now mid will be what? 14 upon 2, which is 7. Okay, now we have to just check which element is in 7th index. So 0 1 2 3 4 5 6 7. Here it is 15. Okay, so mid 7 equal to 15. Okay, and our key was 15. Now compare both of them. We can see that 15 equal to 15. Okay, what does it mean? That element is found in which index? In 7th index. So we'll simply print element found okay. So here we'll just print element found in which index? 7th index. So basically in binary search we just keep eliminating half of the data again and again. That's why binary search is super fast. Okay, and I would like to compare the linear search and binary search. So what we do in linear search is we check every element. We check every element linearly, one after one. Okay, so it takes, obviously it takes more time. And in binary search we directly jump to the middle, reduce search space, and yeah, so that it's much faster than linear search. So yeah, do comment if you want any particular topic explanation. And yeah, to get the codes, check the description box. See you in the next video. Bye bye. Tata.